So, have you ever found yourself wrestling with a search engine? Trying to find something really specific, maybe like case studies on deep learning and sustainable farming, but not the academic papers.
Oh, definitely. And you just get pages and pages of stuff that's kind of close, but not quite it. It's super frustrating.
Exactly. It feels like you're using this blunt tool when you need, like, a scalpel.
Yeah.
The web has all this knowledge, but getting exactly what you need is tough.
It really is. And that experience highlights a system built for, well, a different time, maybe.
Right. So what if search could actually understand you? Like, really get the nuance, no matter how complex your question.
That's the dream, isn't it?
Well, that's what we're diving into today. There's this company, Egala.ai, and they're basically trying to rebuild web search from the ground up.
And the really interesting angle here is they're building it specifically for AI, for artificial intelligence. That's a huge shift from search built just for us humans.
Totally. So yeah, this deep dive comes from a presentation transcript we got our hands on. Our mission, to kind of unpack how search is changing, why it's changing now, and crucially, why this matters for you, living in this, increasingly AI-powered world.
Okay, let's set the stage. We got to go back a bit. Think 1998.
Right. Pre-Google chaos, finding stuff online was
Yeah.
hard.
Then Google arrives, you type in Australia, one word, and bam, relevant documents. It sounds so basic now, but back then, mind-blowing.
Seriously groundbreaking.
And the key insight wasn't just finding the word Australia, it was PageRank. This, like, crazy cool algorithm.
Oh, PageRank. Right.
Yeah, it ranked pages based on how many other pages link to them, sort of like authority or popularity built into the web's structure itself. Super clever for its time.
Completely changed the game. Okay, fast forward. Jump to 2021.
Now things get really interesting. GPT-3 is out.
And it felt like actual magic, didn't it?
It really did. You could feed it whole paragraphs describing what you wanted, complex ideas, and it just understood. It gave you exactly what you asked for.
Which makes you wonder, why were search engines, even then, still struggling? Like the classic example, searching shirts without stripes.
And getting shirts with stripes, yeah. It showed they weren't really understanding the query, especially negation, the without part.
They were still stuck on, like, keyword matching algorithms,
That's
fundamentally.
exactly. They see shirts and stripes and think, great, show them shirts with stripes. No real grasp of the meaning.
Okay, so that's the gap. And this is where Exec.ai comes in with their, well, pretty huge idea.
Yeah, a very big idea. They looked at this gap, looked at the power of AI, like GPT-3 specifically, the transformer models, this next token prediction stuff.
Right, the tech behind the magic.
And they thought, what if we build a search engine that uses that deep AI understanding to grasp both what you're asking and what's actually in the documents on the web?
To get exact matches, finally.
Exactly. Understand the query, understand the content, deliver precision. They figured if we crack this, it changes everything. It changes the world.
A world-changing ambition, for sure. And their path wasn't exactly typical, was it? They got into YC, raised money.
YC Summer 2021, yeah. Raised capital and then did something generally not recommended for startups.
Which was?
Spent about half the money on a massive GPU cluster and then basically went dark for a year and a half. Just pure research. No talking to users.
Wow. That takes some serious conviction. Or maybe craziness?
Maybe a bit of both. But they felt they had to. They were redesigning search from the very foundations, applying this AI understanding to the whole web. It required deep work.
Okay, so what was the core technical leap? How did they ditch the old keyword model?
Well, traditionally, search engines build, like you said, a keyword index, an inverted index, basically maps of words to the documents they appear in. Then complex algorithms compare keywords at search time.
Standard stuff for decades.
Right, exactly, threw that out.
Yeah.
Instead of turning documents into lists of keywords,
They turned them into embeddings.
precisely, embeddings. Now, you can just think of an embedding as a big list of numbers.
Okay, a list of numbers. Sounds simple, but I guess the magic is in what those numbers represent.
Exactly. These numbers pack in a ton of information, not just words, but the actual meaning, the ideas, the concepts in the document, even how it's talked about elsewhere. They capture semantics.
So it's not just matching stripe, it's understanding the concept of stripes or the absence of them.
You got it. Embeddings kind of destroy keywords in terms of representing rich information. They allow you to compare meaning mathematically, not just words. It's like a fingerprint of the document's meaning in this high-dimensional space.
That sounds like that AI principle, the better lesson, in action.
Absolutely. The idea that huge models trained on massive data with general learning algorithms often beat clever, hand-engineered features.
So more data, more compute, better embeddings.
That's the core. Train massive transformer models on high-quality web data to spit out these incredibly powerful embeddings for trillions of documents.
And then searching becomes
Much simpler in a way. You take the user's query, even a long one like shirts without stripes, turn that into an embedding.
using the same AI model.
Yep. And then you just mathematically compare that query embedding to the embeddings of all the documents. Find the closest matches in meaning.
And did it work? That shirts without stripes test.
It did. By November 2022, they launched, and boom! It returned shirts without stripes. It could handle paragraph-long queries right out of the gate. People were pretty excited. It felt like a new era for search.
A new paradigm.
Yeah.
And then, like, 2 weeks later,
Kaboom! ChatGPT arrives.
talk about an earthquake.
Okay.
Suddenly, everyone was using this conversational AI.
And it instantly raised the question, wait, if we have these incredibly powerful LLMs that can answer anything, do we even need search anymore?
A pretty fundamental question for XI, I'd imagine.
Oh, yeah. A bit of an uh-oh moment, maybe. But the answer, it turns out, is a definite yes. LLMs need search.
Why is that? Is it just about having the latest information?
That's part of it, but there's a more basic reason. Simple information theory, really. Look at GPT-4, massive model, trillions of parameters, right? Its size is maybe under 10 terabytes. The indexed web, just text, is way bigger, but the whole web, including images, videos, we're talking over 1 million terabytes, exabytes.
Wow. Okay, so an LLM literally can't hold the whole internet. Not even close.
Not even close. And like you said, the web is constantly changing, updating every second. An LLM trained at one point in time is immediately out of date.
So they can't store it all, and they can't keep up.
Exactly. So the conclusion, and pretty much all ML researchers agree on this now, is that LLMs will always need search to access real-time, comprehensive information.
Okay, so they need each other. How does that combination work best? What does search give the LLM?
It allows the LLM to handle really complex, grounded queries. Think about asking, find me some cool personal websites from engineers based in San Francisco.
Right, that's not something an LLM just knows offhand.
Exactly. So the LLM can formulate a query, send it to a search engine like Exa, get back a list of relevant sites.
Which Exa is good at finding because of its semantic understanding.
Precisely. And then the LLM takes that raw information from Exa and synthesizes it into a nice, clean answer for you. That LLM plus search combo, it's becoming the standard architecture. Seems kind of obvious now.
So if LLMs need search, why not just plug them into Google or Bing? Why build something new like Exa?
That's the key insight, really. It's this kind of hidden truth. Google, Bing, the traditional players, they were built for humans.
Built for us. Slow, fleshy humans.
Oh, yeah. Slow flesh humans typing, 2 or 3 keywords, maybe clicking a few links, caring a lot about the UI, the ads, the layout. Google is optimized for what we're likely to click on.
Okay, makes sense. And AIs are different.
Totally different beasts. They gobble up information like crazy. They don't type keywords. They might have paragraphs of context. They don't want 10 blue links. They might want 10,000 data points because they have the patience, the processing power to analyze it all instantly.
So the search results that are best for a human clicking around are not necessarily the best for an AI trying to gather comprehensive knowledge.
Exactly. It's a completely different optimization problem. The best algorithm for humans isn't the best for AIs, and that's the issue. A lot of AI tools today are still plugging into search engines built for humans. It's like a puzzle piece that doesn't quite fit.
Okay, so what does a search engine designed for AI look like? What are Eggs's principles?
Well, first, precision and control. An AI needs the search engine to return exactly what it asked for. No editorializing, no guessing intent based on click data.
Like if a venture capital firm's AI is researching startups like, say, the Next Bell Labs.
Right. That AI agent is going to make tons of searches. It needs an API that just delivers the precise data requested every single time. No fuzziness.
Makes sense. What else?
Context. AIs often have lots of context about a user or a task, maybe paragraphs of text. They need to be able to use all that context in the search query.
Unlike Google's keyword limit, humans wouldn't type paragraphs anyway.
Exactly. Humans are lazy typists. But an AI isn't. XI is built to handle these multi-paragraph queries, using all that rich context to find better results.
And the third thing, you mentioned volume.
Comprehensiveness. Yeah. Humans get overwhelmed by 10 links sometimes. An AI, It can process 10,000 links in, like 3 seconds if you run it in parallel.
So if that VC wants all the AI startups funded by YC,
They mean all of them, not the top 10 Google shows. They want the full list, 1,000, 10,000, whatever it is. Exai is designed to provide that comprehensive knowledge dump and has the semantic smarts to actually find every startup funded by YC working on AI. Google, it literally just can't do that kind of query with that comprehensiveness.
so precision, context, and comprehensiveness, designed for the AI user.
That's the core idea.
This really changes what we even think of as a query, doesn't it?
Massively.
Yeah.
Think about the kinds of questions we asked search engines before, say, 2022. It was mostly basic keywords, right? Stripe pricing, Taylor Swift's boyfriend, that kind of thing.
Yeah, the simple stuff, the top left corner of the query world.
Then LLMs came along and added new types, like explain quantum physics like I'm 5, which actually the LLM can often do without needing to search. It just knows it. Okay. But then you get these semantic queries, people in San Francisco who know assembly language. That's where EXA shines, using embeddings to understand the meaning.
Yeah, it goes even further.
Oh, yeah. You start getting these really complex queries like, find me every article that argues for position X, but specifically not position Y, written by an author who sounds like Z.
Wow. That's like querying a database.
Exactly. EXA's website's product aims to handle that. It turns the whole web into this filterable database. And honestly, new types of queries are popping up all the time now. Expectations for what search should be able to do have just skyrocketed.
So where does EXA see itself fitting into this new, expanded world of queries?
Their vision is pretty ambitious, to be the one API, one single API endpoint that any AI system can call to get any information it needs from the web.
Whatever the knowledge, whatever the query type.
Keyword, semantic, those complex database-style queries, even types we haven't thought of yet. One interface to access the world's information for AI.
And how do they give AIs the control they need? You mentioned filters.
Yeah, the API is designed for flexibility. You can specify exactly how many results you want, 10, 100, 1,000, more. Set date ranges. Search only specific websites or domains.
And choose the search type.
Right. Critically, you can choose between neural search, the deep semantic embedding search, or traditional keyword search. Because sometimes you do just need to find an exact phrase or name.
So the AI gets full control over how it retrieves information.
Exactly. They have this concept like agent mark, an AI agent that's smart enough to combine different search types.
How would that work?
Well, maybe it does a neural search first to find, say, engineers in SF interested in information retrieval. It gets a broad list based on meaning.
Okay.
Then, for each person on that list, it might do a targeted keyword search to find their specific GitHub profile or LinkedIn page.
Ah, using the right tool for each subtask.
Precisely. The idea is that the really capable AI agents of the future will intelligently switch between these different modes of searching depending on the specific information need.
And they have something for deep research, too.
Yeah, a newer research endpoint. You give it a complex research task, and behind the scenes, it runs multiple searches, maybe neural, maybe keyword, maybe a mix queries, an LLM, refines, searches again, and ultimately generates a structured report or a perfect answer for you. It's like an automated researcher using the best of search and LLMs.
Wow. So stepping back from specifically, this whole shift, it feels huge.
It really is. Moving from search designed for humans, clicking links based on keywords, to search designed for AIs understanding meaning, needing comprehensive, precise data. It's fundamental.
And it's not just about how AI agents will work in the future, right? This changes things for us, too. For you, listening.
Absolutely. How you interact with the web, how you leverage its knowledge, that's going to change.
So the final thought maybe is,
Yeah.
what happens when the web isn't just a place you find pages, but truly becomes this massive, filterable database you can query with incredibly nuanced, complex questions? What new kinds of answers will you be able to get when your AI assistant can treat the internet like his own personal knowledge graph?
Imagine asking things we can't even conceive of asking today. That's the potential here.